Hello, class. In this video on correlation, we study the relationship between two interval or ratio level variables and develop numerical measures to express the relationship between two variables. In all business fields, identifying and studying relationship between variables can provide information on ways to increase profit, methods to decrease cost, or variables to predict demand. A better understanding of correlation between variables can help us on descriptive analytics, predictive analytics, and prescriptive analytics. We often begin our study of the relationship between two variables with a scatter diagram. It gives us a visual representation of the relationship between the variables. In particular, what kinds of relationship? In what direction? Is the relationship strong? For instance, a sales manager wants to know if there's a relationship between the number of sales in a month and the volume of advertising that month, and begins the analysis with a random sample of 15 sales in the past. With this data, the number of sales is the dependent variables, typically on the vertical axis. And advertising is the independent variables, typically on the horizontal axis. From the scatter plot, we can tell that sales and advertising are strongly correlated, and more advertising may lead to more sales. Correlation between variables can be categorized into different types. The two charts in the first row indicate no correlation between the two variables. The middle charts show there's a curvilinear correlation between the independent and dependent variables. The chart at the bottom shows a strong linear, either positive or negative relationship between the independent variables and dependent variables. In statistics, covariance is a measure of the joint variability of two random variables. If the greater values of one variable merely corresponding with the greater values of the other variable, and the same holds for the less values, the covariance is positive. Covariance provides a measure of the direction of the correlation, particularly the linear relationship between two or more sets of random variables. If we compute the population covariance, we have COV of x, y, equal to summation of x sub I minus x bar times y sub I minus y bar over n, where n is the sample size. If we compute the sample covariance, then we have COV of x and y equal to s sub x, y equal to summation from I equal to 1 to n of xi minus x bar times yi minus y bar over n minus 1. Here, we demonstrate how to calculate the sample covariance in Excel. We first talk about the version without using the software algorithm. In this case, we have two variables, advertising and sales. We first compute the average of these two variables, x bar and y bar. Then we compute the values of x sub I minus x bar and y sub I minus y bar. After that, we may use the Excel function of sum product to compute the value of x sub I minus x bar times y sub I minus y bar. which is 9.1 in this case. We then divide this value by 14, which gives us a value of 0.6505. In fact, we do have an easy method in Excel to compute the covariance by using its function. We can use covariance.p of x, y for population covariance and covariance.s of x, y for sample covariance. We will demonstrate using this function a little bit later in this Excel file. The correlation coefficient is a statistical measure of the strength of the relationship between the relative movement of two variables. As previously discussed, covariance indicates the direction of the linear relationship between two variables. By contrast, correlation measures both the strength and direction of the linear relationship between two variables. What sets these two concepts apart is the fact that correlation values are standardized, whereas covariance values are not. Mathematically, correlation, CORREL of x and y equal to summation from I equal to 1 to n of x sub I minus x bar times y sub I minus y bar over n minus 1 times s sub x times s sub y, which is also equal to covariance of x and y divided by s sub x times s sub y, where s sub x is equal to the square root of summation from I equal to 1 to n of x sub I minus x bar squared over n minus 1, which is the sample standard deviation of x. We also have similar equation for s sub y, which is the sample standard deviation for y. In statistics, the maximum possible correlation is +1, which means perfect positive correlation. The minimum possible correlation is -1, which suggests a perfect negative correlation. A correlation of 0 implies that there's no linear relationship between the variables. In Excel, we can also call the function of CORREL of x and y to obtain the value of correlation, which is the same for population correlation and sample correlation, because the degrees of freedom is canceled out in computation. Okay, now let us open the Excel file. You may pause here and open your Excel file at first, and then please follow me step by step to fully master the skill of using these several functions. Okay, so as we can see from this Excel file, we already have the data, the 15 samples of the sales and advertising in this. In this Excel file, I'm going to show you two ways to get the covariance and the correlation. We are going to start with the first one. As you can see from here, I already get the covariance value of the population. And you can see from here, the equation, that's covariance.p, and we have the data sales and the data of advertising. So let me try to repeat this whole process for you. That is equal to covariance.p, given that we are going to get the population covariance. And from the reminder from Excel, you can see that we need to get the data of array 1 and array 2. Array 1 actually in our case will be the sales, right? So we get the sales, comma, and we are going to get advertising and parentheses. That's the equation for population covariance. And you just need to enter here. As you can see, you get exactly the same value for what I got previously. Now, let me try to show how to get the covariance for samples here. That is equal to covariance.s, because we are going to get the sample covariance. The same thing, parentheses, and the sales data, comma, the advertising data, parentheses. And we say return, and we got the same value I type in. Actually, I got it previously. Okay, now, after we got the covariance, we can get the correlation value here. As I put a memo here saying that the value we got here is the same for population and sample. And I've typed in the correl, the CORREL, and we have X and Y in the equation. So let me do that again. So that we CORREL, correlation, and of two variables, and you put comma, the same like we did in covariance, and parentheses, and return. So you got the same correlation as I previously got over here. Okay, as I said, we have second approach to get the covariance. I want to mention that the data we got from here actually will be only about the population covariance. But anyhow, let me go to the data and the data analysis. Okay, this is the software we use primarily in this course. So we get data analysis. As you can see in the pop-up, we have the covariance. You have only one choice. You don't have the sample or population covariance. So you have only covariance. So we say, okay. And it asks us to type in the input range, right? Input range. And our data will be in column. So we are going to keep the default column. And we are going to covariance. I'm going to select the entire area because we have only one input over there. I did not include the data of the label, so you don't have to put there. But in case you want to get the label into your analysis, you can do so. But let's try to restart. You get sales and advertising, and that you include the data and the labels. In this case, you need to click on the labels. Okay, so to make it easier for us, I just want to output the data just exactly over here so that you can see it easily and compare it with the first method. I'm going to say, okay, that's it. Okay, so we just need to say, okay, and we are going to get the covariance. Okay, so this is the covariance. You can see it exactly the same as the population covariance we got previously. Now, let's go to the correlation. I'm going to go to, again, the data analysis, and you can see the correlation over here. Again, you have only one choice of correlation, and we are going to say, okay, and you're going to put the input, and so I'm going to collect both of them, okay, including sales and advertising. I also include the labels, and I'm going to put labels here. The advantage of including the labels, as you can see the sales and advertising in the final output. So that will give you kinds of more information about the correlation. So this is definitely actually is preferred. Again, I'm going to put the outcome on the same C. So I'm going to put default by here. because I already put the name of the correlation. So it will be easier for us to identify the correlation. So I'm going to say, okay, because I have input everything. Okay, so you can see that the correlation between sales and advertising will be 0.8348, which is exactly the same as what we got in the first approach. Okay, so this is the way you got the value of covariance and correlation from Excel. And hopefully you can practice it if you have not done so. But I hope you did follow me step by step, and hopefully you enjoy it. So we just show how to use Excel to call these functions of covariance and correlation. Actually, there are many different types of correlations. And as we can see over here, there are 3 different kinds of correlation graph. And these different kinds of graphs show us different kinds of strength of correlation. Okay, so in chart A, the correlation is perfectly positive 1. It means the correlation is very strong, right? In chart B, there's 0 correlation. So you cannot see a very strong pattern or relationship between the X and Y. And in chart C, the correlation is perfectly -1. It's also very strong, but in a negative way. The direction of the linear line itself does not affect the correlation value, which is to be addressed in the linear regression modeling we are going to discuss in the next couple videos. In practice, most of the correlations are actually in the between of the -1 and +1. For example, here we have correlation value of -0.7, like this. And we have positive 0.9. This is a very nice linear relationship. And we have correlation of positive 0.4. However, we should be cautious about spurious correlation or spuriousness, which occurred when 2 factors appear causally related to one another. But in fact, they are not. For example, the price of cars and the price of bread might have some type of correlation in data, but it's difficult for us to establish a relationship between these 2 variables. The reason for spurious correlation could be caused by similar coincidental movement or a third confounding factor. To spot spurious correlation, we might use our common sense, increase the sample size, demand a higher confidence level, and so on. In this video, we have introduced the concepts of covariance and correlation and show how to obtain the values using Excel. Once we understand the concepts of correlation, we are ready to talk about simple linear regression